Thank you so much. And thank you to all of our attendees here today. It is mine and Annie's honor to share with you the work that we've done with our team in AI and data science for suicide prevention, and to share with you the best practices that we found. Now, the work that we've done stems in a belief in that data can be used for good if we choose to make it so, that data science can save lives if we put in the extra effort. So I'm going to be starting with the non-technical success factors and then switching over to Annie later in the session to talk about the technical success factors. And when you get started in data science and AI for good, the most important part is to find an opportunity and a cause that truly motivates you. What we found is that there are going to be hurdles that you could never possibly dream about in your area, because frankly, you're paving new ground, and that's a great thing. But what you want to do is make sure that you have that motivation to get through it on the nights and the weekends when you just want to bang your head against a wall. And so for us, the reason suicide prevention became our cause was firstly that it's important to me. I lost a close friend to suicide in 2015, and like many survivors of suicide, looked back and analyzed the situation and thought, what could I have done to have prevented it? What indicators did I miss? What, being an analytical nature, what analytics could have helped at that time? And then Annie has actually been doing some great data science and not suicide prevention, but data science for good work throughout Vancouver, which by the way happened to be where Erica lived. So what we decided to do was, because Annie has a big heart and would take on any cause, and suicide prevention was important to me, we opted to make suicide prevention our cause. Now, the next thing was to determine within suicide prevention, what were we going to work on specifically? And when you look at the area, it is incredibly underinvested in. There are tons of opportunities for data to do good, all the way from personalized recommendations. For example, could I have known that my friend Erica was close to suiciding based on activity on her cell phone or her social media presence and status and activity? Could I have known based on the way that she was speaking, or the way that she was actually writing? So could text analytics play a factor in there? Or should we go from a different perspective? Instead of like the personalized perspective, should we take a perspective going from the larger population? And what we did was, and this is thanks to Erica's father, who shared this research with me, we chose to take a more global perspective, because it turns out that, and this coincidentally, this research came out of Vienna just around the time Annie and I were looking at these different opportunities. It turns out that when a celebrity or someone else who dies by suicide that's highly publicized, there actually is a 13% increase in the national suicide rate. There had been a fair amount of work on this problem done by researchers backed by the WHO and CDC, but what we found was that the research that they put together and the findings and the recommendations didn't have a very high adoption level. And so we saw this as a great opportunity to potentially partner with them and to increase the adoption level of their guidelines, and in that way benefit the other efforts without potentially coming into conflict with, for example, other mental health apps, right? We figured that the space is so big that we can find somewhere to do good that supports everyone else in the area. And so I reached out to our partner, Dr. Dan Reidenberg, and he began this research in the 1990s. So as I mentioned, it's backed by the CDC and the WHO, and it's one of the WHO's 7 priorities for suicide prevention. And what's shocking about the research is that it's based on the idea that there's always a population that is at risk for suicide. And to compare to 13%, the other numbers are that if somebody knows somebody who dies by suicide, their risk level goes up typically by 3 to 5%. If you lose somebody who you had a personal relationship with, your risk level tends to go up by 5 to 50%. And in cases where it was somebody very, very close to you, like me, my risk level went up by 75%. And a lot of it has to do with the way that we talk about suicide. And the way the guidelines were written were specifically tailored to reporting outlets, so news and entertainment media, but these are generally applicable to also social media and the way that we converse, because it has the same impact. I'm just going to take a second to go through those guidelines. And the first one is to avoid discussing or depicting the method or location of somebody's suicide. Doing so actually not only leads to an increase in suicide, but a disproportionate increase in that specific method. The second one is don't use stigmatizing terms like committed. We commit sins, we commit crimes, we don't commit illnesses. You wouldn't say that somebody committed cancer. So by that same logic, we can say somebody died by suicide or somebody suicided. Next, don't share the content of a suicide note. It's not actually helpful in understanding the suicide, and unfortunately, people who may be at risk who identify with that note may be more likely to suicide themselves. Don't blame. It's really hard not to do, and I will tell you, as somebody who lost someone personal, it's really easy to blame yourself, right? You ask yourself, what did I do wrong? But suicide is much more complicated than that. It's rooted in mental illness, but there's so many factors involved that you really can't blame anything or anyone, which is really tough to not have answers. Next is don't glamorize, romanticize, or sensationalize suicide. I think this one's probably given what we already talked about, but it's so easy for us to want to know more, to look for those answers, and doing so to intentionally elevate these details. And then the last one is, keep in mind that the topic of suicide, like we're talking about today, can be triggering. So if you ever write an article about it, if you ever talk about it, please make sure to include National Suicide Hotline, or for example, crisis text line, for which you can reach by texting home to 741-741. And so Annie and I also chose this problem because not only was the research well established from a psychological and neurological perspective, but the problem lent itself well to NLP and ML and data science because the data was in the public domain, right? We can look at articles, we can look at reports on suicide, and we had a fantastic partner. One day I called Dr. Dan Reidenberg and asked him, we would love to partner and to, support the amazing work that you've been doing for decades at this point. And he said, yes, absolutely. So that was a key partnership, and something I would also recommend is don't go it alone. Make sure that just as in data science, you have that domain expertise that's complementing the work that you're doing and modifying it. We have learned so much throughout this process, and we're still learning. The next is to make sure that you have sponsorship. So if you're maybe working on a small scale and you're volunteering your time to a nonprofit organization using their tools, this may not be applicable, but if you're trying to do something on a large scale, as Amy and I, our team, are doing, it's really important to have appropriate executive sponsorship. And we are incredibly grateful to have Cisco's Chief Data Officer, Shanti Iyer, and the Head of Data Science, Sanjeev Patel, as our executive sponsors. And what I can tell you is they don't just ensure that things like our compute are paid for, they can make connections that we wouldn't be able to make and move mountains that could potentially get in the way. So when you're looking at a large scale or doing it from a corporate perspective, having that sponsorship with people who care about this cause just like you do can be a make or break. And so with all of these things in place, with us having identified the cause, within the cause, how we wanted to contribute based on what was doable, what was feasible, what we felt we could make a competitive differentiator in, with having our executive sponsors and our partner, we were ready to start the work. And so now I'd like to pass it off to my partner in good, Dr. Annie Ying, to talk about what we've accomplished and the technical elements.
Thanks, Jen. Thank you so much, Jen. I just want to reiterate the importance of this cause and why data science before I jump into the technical side. Then for the rest of this talk, I will also show a demo of the tool, and then I will jump to the success factors that led to this data science work on identifying problematic texts in articles, so that one day journal media organization can pre-screen articles and reduce harm of suicide contagion effect. So I'm going to share my screen now. Oops. I want to share my screen. Okay. I just want to hope people can see my screen. I just want to reiterate that after high-profile suicides, researchers found that there's a 13% increase in suicide rate. This is very staggering. Another statistic, knowing that after these high-profile suicide and the way the news articles are talking about the suicide would increase the suicide rate, we started this effort by having volunteers within Cisco looking at articles about suicide. What we found was that these volunteers label these articles as breaking some of these guidelines that Dr. Dan, Jennifer mentioned. Dr. Dan proposed these guidelines to reduce the suicide contagion effect. So what we found was that 88% of these articles that were looked at by our Cisco volunteers, 88% actually violated more than one of these guidelines. Throughout our work, we also later found that by applying our tool on the set of articles, we found, in addition to the ones labeled by volunteers, 9% more of these articles actually we found one or more guidelines being violated. So as a result, what does all this mean? That really means that only 3% of the articles in our data set actually did not violate any of the guidelines. So this is a very staggering statistic that the guidelines exist in media reporting, but they're not adopted. So this is exactly why we started this work on marking the text in a news article, identify problematic text, and so that journalists can start changing the way they write, and they would also know how to fix this issue. So I'm going to show you this tool we have developed. This is using just like a basic approach that I'm going to talk about within the data science, and I'll tell you more about the internals later on the top. But here, this is the tool that is already available. So on the right-hand side, you see 4 of the guidelines that are from Dr. Dan's guidelines. You see the color here. You can match the color coding with the problematic text that are highlighted in the text that I already entered beforehand. So I'm going to now hover to one of the problematic texts. So this text visually depicted the suicide method, which is harmful for individual at risk. In this pop-up, you can also see you also have a link to find out more about why this particular way of talking about suicide is harmful, and then also suggestion as to how you can rewrite this text as a journalist to avoid this. So here there are 3 more guidelines using appropriate language, like what Jen said, destigmatizing suicide by not using words like committed, avoiding blame, and also including help information that could really help out individuals at risk of suicide. So yeah, here we go. This is our tool. Reporting on suicide.cisco.com is already live. So having shown this demo, I'm going to go back to my slides. Yeah, I'm going to talk about success factors within the data science work that brought us here. So I'm going to break up the talk into three. I'm going to attribute to three success factors. So first of all, you know, even though I am a machine learning, I have a machine learning background, I'm a data science manager, I'm a data scientist, but machine learning is not necessarily the best approach for all use cases. Second, you know, again, I'm a quantitative person, but you know, people is really a big part of data science, not just the numbers, not just the algorithms. And thirdly, you know, I know part of the audience must have a lot of expertise in data science, will know that data augmentation can be very important in machine learning problems these days, especially when you're dealing with a problem with a small set of labeled data. So with that, I'm going to start with the first success factor. So machine learning is not necessarily the best approach for all use cases. So especially in our case, we have, even though, you know, news articles, we can, you know, access it with APIs, and many of them are free. We have a very small label set. So meaning we have a small number of articles and sentences that are marked as violating the guidelines or not, which is a problem that we're dealing with. We want to be highlighting the text with problems that could lead to the suicide contagion effect. So in our data, volunteers marked up 1,600 articles. However, if we talk about one particular guideline that I'm going to talk about more extensively for the rest of the talk, which is identifying the method of suicide in text, we only found there are 281 articles. This is a very small set for a machine learning problem. So what I want to highlight here is more of a project management approach of having a fast iteration of building a really basic approach, measure performance, and then learn from it. So this is kind of like a lean startup approach that we took. So with this approach, in 2 months, we built up a approach using kind of a dictionary-based method, as opposed to a machine learning method, given the small data size. Our goal there is to validate the solution both quantitatively and qualitatively. So let me just say a few more things what that means. So in terms of the quantitative side, so we identify 4 guidelines that are both impactful to identify and feasible to implement. So within these 4 guidelines, we use the dictionary-based regex method and implemented a quick prototype. So with this very simple basic approach, of the 4 guidelines, actually 2 of the guidelines perform really, really great, almost perfect performance. In terms of identifying stigmatizing texts like committed suicide, and also like identify articles that are missing that educational, that the hotline and like support part. So great, with those 2 birds knocked out, I want to talk about the rest, the other 2, that the simple approach can't really perform well. So this is the exclude suicide method and also identifying articles containing blaming text. So there, what we found was that with the with this simple dictionary-based regex approach, we got a baseline of precision recall, and with two different approach, we have this precision recall trade-off that you often see. That's fine, this is a baseline. So with that being known, we brought it back to Dr. Dan, and also do further user testing, and basically found that if we were to put effort, what should we put? Is it the suicide method or blame? We found that, okay, suicide method is the approach we should put more work, as this is the more important guideline. So then we know for the rest of the effort, we will put more effort in NLP and machine learning in that. So this quick iteration agile approach really help us to determine where to go, and also get something up and running in 2 months. Then continuing the story on this kind of non-machine learning approach, we made a second iteration on attacking the identification of suicide method. So we looked at the results from the dictionary-based approach. So here are some sentences that the dictionary approach would basically produce a false positive. So something like he jumped into action, or jump to a conclusion, as opposed to jump off the height and die by suicide. So these are what the tool caught wrong by the regex approach. So this is great. We learn from that and improve on this rule-based approach by understanding the category of suicide. How we did that was we looked at Wikipedia categorization of suicide methods and then coded up these patterns. So for example, there's a pattern on jumping off somewhere of a height. So these are some examples of that lead to her death from our premise window and so on. And then basically coded up these patterns and match sentences according to that. With that approach, we actually achieved a really, really good performance, very high precision, especially. So we are really happy with this result. But what I'm going to continue the story later on is that we were still interested in a machine learning approach, because even though precision is high, these coded patterns may not necessarily generalize super well. So we want to try the machine learning approach and see where that brings us. So at this point, now let me move on to the second success factor, which is people. People is a really big part of data science. So I mentioned we wanted to use this lean startup approach, build, measure, learn, and evaluate results both quantitatively, which I'll show you, but also qualitatively. So the qualitative part is basically user testing. We want to see the real impact of this tool on some users. So what we found was that, so one of the highlights from the user testing is that suicide method was indeed perceived as most harmful. So we were really happy to learn about that, because this is actually consistent with research literature. And as a result, it gives us some confidence that the approach we're taking, this whole user interface, is going to be, at least for now, as we understand it, works as the theory predicts. So what else can we learn from user testing? So understanding the real world impact beyond just the numbers, beyond just the precision recall and F1 measure. I'm a data scientist, I'm a data science manager, I am very much drawn to the engineering and building. If I have all the time in the world, I would be just building. But it's super important to measure and learn from it, reprioritize your priority, learn the UX. What we think are intuitive to the users or what fits the workflow may not be the case. We found actually a whole list of issues with the user interface. For example, even as simple as just changing the ordering of the guideline to put the most important guideline up front. Or the color coding wasn't very obvious. Or like we had too much text and people can't really pick out the guidelines easily. These seem to be things that are very trivial and actually not even that related to data science. At the end of the day, we're using data science to solve a problem. So it's a whole package. We have to also evaluate the user interface of, in the front end of the data science solution. The next step on that front is in terms of prioritizing our efforts and understanding how the solution fit into the real world, fit into media organizations so that they can use this tool to pre-screen articles. That would really mean that we can start, correcting this bad practice of having the problematic text in the articles and, start saving lives. So how are we going to do that? Well, we are in the process of performing some user interviews to see how our technology would fit into the workflow of the media organization, and also want to understand better how the actual output of the data science, how helpful and how accurate are they in real life. So just want to, close up that this second success factor. I'm talking about that people is really important. User testing is important. And Jen mentioned and emphasized a lot, that partnership with experts like Dr. Dan, and also like partnership, sponsorship from, within a company. All these things, seem non-data science related, but totally affect the impact of the data science work. So now I'm going to move to a more technical part on data augmentation. So I want to say that again, we have this 1,600 articles that were graciously labeled by volunteers in Cisco within our company. When we're looking at particularly the single guideline on identifying method of suicide, we only have 281 articles. And of those, only about 400 articles are marked as harmful. This is a very, very small data set for any machine learning model. So, these days, BERT is really popular, state of the art. So we offer the approach to fine-tune BERT for this sentence classification problem. So sentence classification problem of given a sentence, is this a sentence that contains the suicide method or not? Binary classification problem. So I think this audience is very technical. I'm sure there's members of the audience who already testing out with BERT and building amazing models with BERT. But in case there are audience members who need a quick explanation, here it is, BERT. So BERT is the language representation model trained based on neural net. So for the audience member who don't know what this is, I can give a quick analogy. So think of this as peekaboo on the sentences. So you have sentences with words in a big corpus like Wikipedia or book corpus. you hide some words smartly and then train a model to predict those hidden words. So with that, the model, trained on this large corpus, actually understand a lot of the nuances and semantics of language. So the reason why this model is so popular is that with this step, you can actually use this model on other tasks, like our task of sentence classification. So this is what we mean by fine-tuning BERT. So we take BERT that is pre-trained, and then we bring it into our problem of sentence classification for SUSE method, and it will actually work really, really well. So this is one of the breakthroughs from this couple of years in NLP and neural net and deep learning. So how do we fine-tune? I don't want to go into a lot of details, but basically this is like transfer learning. This whole area of fine-tuning BERT for another problem like ours in suicide method sentence classification. We took the BERT model and added one more layer, a dense layer, so that we put the classification in place. So for those who are data scientists and want to know the architecture that we used, we basically use the CLS one so that we can do a sentence level classification and discard the ones that are on the token level. So I'll just leave it at that. We actually wrote a paper on architecture and submitted. So hopefully it will be accepted. I'm more than happy to share. So, okay, with this BERT fine-tuning approach, we apply it to our data set of the sentences that were labeled by the Cisco volunteers. Added to it some additional sentences from Wikipedia pages of notable people died by suicide. So we extracted this part of the Wikipedia page, which has the suicide method. As a result, we have over 1,000 harmful sentences as positive examples. Unfortunately, even with this additional data augmentation on the from the Wikipedia pages, the precision is still especially low, and F1 too, not great. So then we did the next iteration, which is to do text augmentation. So I'm going to talk about like three things we did on this front. So first of all, the first one is context. Using like contextual word embedding to alter words in sentences. So for example, a sentence like he committed suicide by jumping off the bridge, we would change our bridge to roof, and so that we can add one additional positive sentence into the data set. With this approach, we generated 10 sentences per positive sentence. So we basically tenfold increased our training set. So with this approach, we further improved the performance from 65 F1 to 78 F1. We still feels like there's room for improvement, especially after an error analysis. What the error analysis told us was that we saw sentences like he committed robbery by jumping off the wall. That was one of the generated sentences. And this is not a good positive example. This is actually negative. It should have been the label should have been negative. So the problem with this text is we needed to also make sure the sentence talks about suicide or the article talks about suicide, and otherwise filter out the ones that are not. So with this filtering approach, we increased the F1 from 78 to 89, and especially increase the precision. That's awesome. So finally, I'm going to talk to you the third method in what we did in text augmentation. So in this case, I want to, so in this case, what we did was that we have a sentence and we replace it by variations of the same action. This involves some natural language processing to do so. Show some examples of that. So using this approach, again, we increased quite a bit from the baseline of bird, not using any text augmentation, from 65 to 88. But like if we combine all these three techniques, so contextualized embedding, filtering out articles not talking about suicide, and also this one rule-based, we increased from 88 to 91. And at the very end, we basically increased the data set of harmful sentences from about 400 sentences to I would say 24. So by that you can see how much it affected the performance from F165 to 91. One more thing I want to highlight in the slide is that it's really interesting in terms of our journey in the data science. You know, we started off without using any machine learning, and we were able to actually get to really high performance of 92. Then we switched to machine learning using BERT, you know, a really powerful language representation model. And we ended up going to 91. So at deployment time, this is an interesting question, right? Which one should we deploy? This is a really good question. You know, in terms of the computation side, you know, obviously the non-machine learning approach would be, you know, the best. It's the simplest to deploy, cheapest to deploy. It has high precision, which is actually what experts like Dr. Dan told us, that getting, you know, marking up sentences and saying that it's right is more important. So precision is more important. Whereas the deep learning approach, it's able to generalize and catch cases that are unseen better in a way. So higher recall, but the precision is lower. So it is an interesting question in terms of what to deploy. And I would love to report back, deploy both, and report back what would be the ultimate answer. But you know, this is a very, very interesting question in data science. Yeah, I just want to reiterate these three kind of best practices, success factors that helped us in terms of data science side. Want to say, you know, as much as I, as a data scientist with the engineering background, want to do everything machine learning, it's not necessarily the best approach to start, given, you know, a lot of the real life cases, we have small data, and also we want to be, you know, we are trying to solve a problem, we're trying to save lives. We need to keep reminding ourselves what is the best solution, whether or not it's machine learning or not. And then also keep in mind this agile cycle of build quickly, measure, learn, so that you can build the right thing next time, rather than, okay, we could be the heads down playing with BERT and like coming up with the most accurate algorithm, but then, you know, we could be disconnected from the problem, and waste a lot of time in that. So this agile methodology and not only focusing on machine learning really helped us. People, in terms of user testing, in terms of connecting to experts, domain experts like Dr. Dan, super important in the data science success. And then thirdly, data augmentation. Nowadays, with things like BERT and with machine learning, this is a challenge. How can we get the right data set to train these powerful models? I want to end the talk by reiterating Dr. Dan's guideline that we have included in our tool, reporting on suicide.cisco.com. These guidelines, not only we can highlight it on the article, and not only violating this guideline could be harmful for people when it's seen in an article, but even in our everyday conversations, even when we post something on the social media, how we talk about suicide. I mean, these guidelines, as Jen said in the beginning, really could be useful for any type of communication. So I just want to reiterate that to conclude the talk. So basically, exclude suicide method. Don't visually depict the suicide method. I noticed, in the talk, because we are detecting suicide method, I have shown a lot of it. So these are, could be, I want to tell at-risk individual, if you feel like you need help, please reach out for help. So as said in the last guideline here, Jennifer mentioned in the beginning some help information. So the rest of the two guidelines, avoid stigmatizing suicide, like using the word commit. And then lastly, avoiding assigning blame. Suicide, complicated, it's a complicated thing. Not, we cannot only attribute to one factor. And a lot of the times, mental illness is at play. So blaming one factor is really harmful to at-risk individual. So with that, thank you very much.
It looks like we have a question in the Slack channel.
Let me go to the Slack channel.
I can read it to you, Annie.
Oh,
From
sure.
Gaurav, who's asking, how do you measure the results of the model in fact actually helped in improving the suicide prevention rates? Basically, correlation, causality here. How do we measure success of the models?
I mean, very interesting point. I mean, we are looking to measure this by adoption rate. For us, I would like to lean on to experts like Dr. Dan, who is doing research on that, on actual measurement in terms of how it affects the suicide numbers. But as a data science, for the data science part, for us as Cisco, we would want to look at this intermediate measure of how much these guidelines are adopted, because we know from research that when these guidelines are not satisfied, it's already shown that there's an increase in suicide rate.
And also that's something that we can measure pretty well with high fidelity, right? We already have the ML model in place to look at articles and see if they adhere to or don't adhere to the guidelines. So we can, at various intervals, see, are the guideline adoptions going up? Are they going down? Are they staying stagnant?
Yeah.
And our hope is that through ethical reporting, as well as through people like you sharing these guidelines, that the adoption will go up over time. And of course, our partnerships with news and entertainment media as they start to adopt it and change the culture and how we speak about suicide and mental illness.